Hello and welcome to AWS Certified Solution Architect Associate course. This is a continuation of concepts and components, and in this video we will discuss about compute unit. So in compute unit we have four components: EC2, that is Elastic Compute Cloud, auto scaling, elastic load balancing, and workspaces. So what is EC2? EC2 is a AWS terminology for servers. In an on-premise environment, we use servers for compute activity. So that is same in AWS, and it has been named as Elastic Compute Cloud. How does it differ from a server in on-premise environment? So in AWS, we can launch a server within few minutes. That means there are already server images known as AMIs which are present in AWS, and we can launch them in a fraction of minutes. So that is where the Amazon EC2 differs from server deployment in an on-premise environment. And one more thing here we have to notice is we can launch multiple EC2 instances and in one go in AWS. So that is also a big difference from on-premise environment. Now the second component is auto scaling. Auto scaling helps you to maintain application availability and allows you to scale your Amazon EC2 capacity up or down automatically according to conditions you define. So let's suppose in scenario in which you have a single server, and on that server some applications are running. So what happens when that server goes down? Your application will definitely go down and user will face an outage. So now how to resolve this issue in cloud? So in cloud, what we have done is they have created an auto scaling group. That means if a bunch of servers are hosting any applications and one of the server or multiple servers goes down, it will generate another fleet of servers to compensate that loss of servers. So that is where auto scaling provides you high availability. So to achieve this, we have to define some conditions in AWS that will trigger this fleet of new EC2 instances. You can use auto scaling to help ensure that you are running your desired number of Amazon EC2 instances. That means you can even keep the number of EC2 instances fixed to using auto scaling. Auto scaling can also automatically increase the number of Amazon EC2 instances during demand spikes to maintain performance and decrease capacity during lulls to reduce costs. That means if sometimes if your application is overloaded, your server is overloaded, so in that case you need some more resources to compensate those spikes. So in that case, auto scaling will generate few more instances to help you compensate the load. So and the same happens when the uses decreases. So in some cases, if your CPU or memory utilization of the current fleet of servers goes down to a certain level, then you don't need that many number of instances. So you can reduce the instances by using auto scaling, and this will save you some cost. Auto scaling is well suited both to applications that have stable demand patterns or that experience hourly, daily, or weekly variability in usage. So this is a very intensively used service in AWS to provide high availability to applications. Now coming on to elastic load balancing. Elastic load balancing automatically distributes incoming application traffic across multiple Amazon EC2 instances. It enables you to achieve fault tolerance in your applications and seamlessly providing the required amount of load balancing capacity needed to route application traffic. So elastic load balancing is basically the load balancer we use in our on-premise environment. But the difference here is in elastic load balancing, it will do a regular health check of all the nodes which is connected to it. And if some node is not healthy, it will not pass the request to that node. Elastic load balancing offers two types of load balancer that both feature high availability, automatic scaling, and robust security. These include the classic load balancer that routes traffic based on either application or network level information, and the application load balancer that routes traffic based on advanced application level information that includes the content of the request. The classic load balancer is ideal for simple load balancing of traffic across multiple EC2 instances, while the application load balancer is ideal for applications needing advanced routing capabilities. Application load balancer offers ability to route traffic to multiple services or load balance across multiple ports on the same EC2 instance. So now moving on to workspaces. Workspaces are nothing but the virtual desktop environment, and it delivers desktop as a service from AWS. Amazon Workspaces is a fully managed, secure desktop computing service which runs on the AWS cloud. Amazon Workspaces allows you to easily provision cloud-based virtual desktops and provide users access to the documents, applications, and resources they need from any supported device, including Windows and Mac computers, Chromebooks, iPads, Fire tablets, Android tablets, and Chrome and Firefox web browsers. With just a few clicks in the AWS Management Console, you can deploy high-quality cloud desktops for any number of users. With AWS Workspaces, you pay either monthly or hourly just for the Amazon Workspaces you launch, which help you save money when compared to traditional desktops and on-premises virtual desktop infrastructure solutions. So this covers the compute unit of AWS infrastructure. Now in next video, we will discuss about other components of AWS infrastructure. Thank you for listening. Have a good day.